In 1942, as German fighters dominated the skies over Europe, an American engineer who had been rejected by the Air Force due to vision problems created the impossible, a fighter that not only equaled the feared Messerschmitts and Focke-Wulfs, but surpassed them in almost every way. German pilots called it the American Beast. The Allies called it their savior. This is the story of Clarence Kelly Johnson and the P-38 Lightning, the twin-engine aircraft that defied all the rules and changed the course of World War II. Clarence Leonard Johnson was born in 1910 in Ishpeming, Michigan, a small mining town in the heart of the state's Upper Peninsula. He was the seventh of 9 children in a family of Swedish immigrants who worked in the iron mines. Life was hard, money was scarce, and his future seemed preordained to work in the mines like his father and older brothers. But Clarence was different. From an early age, he was obsessed with understanding how things worked. He dismantled clocks, built cars from scrap materials, and spent hours watching birds fly. The way birds controlled their flight, adjusting their wings and tails with millimeter precision, fascinated him deeply. He filled notebooks with drawings of imaginary flying machines. At 13, Clarence had a life-changing experience. A traveling aviator arrived in town with a biplane, offering paid flights. Most people saw it as a dangerous novelty, but Clarence saved every penny he could until he had enough for a 15-minute flight. When the plane took off and he saw his town shrinking below, something clicked inside him. He knew exactly what he wanted to do for the rest of his life. The problem was that boys from poor families in mining towns didn't become aeronautical engineers. There was no money for college. There were no connections or opportunities. But Clarence had something more valuable than money: sheer determination and an extraordinary mind for mathematics and physics. At school, he devoured every science book he could find. Teachers noticed his exceptional talent and encouraged him. One of them lent him engineering textbooks, which Clarence read by candlelight after long workdays helping his family. He didn't just read. He memorized equations, solved complex problems mentally, and visualized aerodynamic forces in 3 dimensions. His classmates began calling him Kelly after he got into a fight defending a girl who was being bullied. The nickname stuck, and Clarence went by Kelly Johnson for the rest of his life. The name sounded more American, more confident, more fitting for someone who planned to achieve the impossible. When it came time to decide on college, the Johnson family had no resources, but Kelly had accumulated perfect grades and impressed all his teachers. He earned a partial scholarship to the University of Michigan, supplementing with night jobs in restaurants and auto repair shops. He slept 4 hours a night, studied obsessively, and still found time to build model airplanes that he tested in makeshift wind tunnels. The university professors quickly realized that Kelly was no ordinary student. He saw engineering problems in ways others couldn't. While his classmates were struggling with equations, Kelly was already 3 steps ahead, visualizing entire solutions in his mind. He wasn't just learning aeronautical engineering, he was reinventing it. During his college years, Kelly developed a philosophy that would guide him for the rest of his career. Simplicity is efficiency. The best designs aren't the most complex, but those that achieve maximum performance with minimal complication. It was a revolutionary idea in an era when engineers tended to overcomplicate designs, but Kelly had a problem that threatened to end her dreams before they even began. Kelly Johnson graduated in 1932 in the midst of the Great Depression. The American economy was collapsing. Factories were closing, millions were unemployed, and jobs for newly minted engineers were virtually non-existent. But Kelly had a specific dream: to fly in the United States Army Air Force as a test pilot and engineer. He presented himself for recruitment with confidence, carrying his honors degree and glowing letters of recommendation from professors. The initial physical tests went well. Kelly was in excellent physical shape. The mental aptitude tests were exceptional. He scored at the absolute top. It seemed his dream was about to come true. Then came the eye exam. Kelly had suffered from moderate myopia since childhood, something he had learned to compensate for so well that it rarely affected his daily life. But military standards were uncompromising. Pilots required perfect vision, no exceptions. The military doctor looked at him sympathetically and uttered the words that shattered Kelly. Rejected due to visual impairment. Kelly tried to argue. He could wear glasses. His vision wasn't that bad. He had compensatory abilities. He understood aerodynamics better than any other candidate. None of that mattered. The rules were absolute. He was permanently disqualified from flying in the Air Force. The rejection was devastating. Kelly had built his entire life around that goal. He had sacrificed years, worked himself to exhaustion, overcome immense obstacles. And it was all negated by something completely beyond his control. Many would have given up right then and there, found another career, abandoned aviation. Kelly Johnson did the opposite. If he couldn't fly the planes, then he would create the best planes the world had ever seen. If the Air Force didn't want him as a pilot, he would become so valuable as an engineer that they would beg for his contributions. Rejection didn't destroy him, it transformed him. He landed a job at Lockheed Aircraft Corporation in Burbank, California in 1933. It was a junior position, low-paying, doing basic technical work. But Kelly saw it as his gateway. He worked longer hours than anyone else, volunteered for the most difficult projects, and consistently delivered brilliant solutions to problems that baffled senior engineers. His first major contribution came just months after being hired. Lockheed was developing the Electra, a twin-engine transport aircraft. During wind tunnel testing, the plane exhibited worrying instability under certain conditions. Experienced engineers were perplexed. Kelly, the rookie, studied the problem obsessively in his spare time. He identified the problem as the interaction between the twin tails and the airflow from the engines at specific angles. His solution was elegantly simple: redesign the angle and positioning of the tail surfaces. Senior engineers were skeptical. How could a new graduate see something they couldn't? But testing proved Kelly absolutely correct. That moment established his reputation. Kelly Johnson wasn't just competent. He had an intuitive understanding of aerodynamics that went beyond equations and theory. He could visualize airflow, anticipate complex behaviors, and create solutions that others couldn't imagine. But his greatest test was yet to come. And when it arrived, Kelly would create something that would change aerial warfare forever. In January 1937, the United States Army Air Corps issued a seemingly impossible specification. They wanted a high-altitude interceptor fighter capable of speeds exceeding 360 meters per hour at 20,000 feet. To put this in perspective, the fastest fighters of the time barely exceeded 300 meters per hour at sea level. But there were even more challenging requirements. The plane had to reach 20,000 feet in 6 minutes. It had to have heavy weapons. It had to have extended range. And it had to be stable and controllable in all flight conditions. Aircraft manufacturers across the country looked at those specifications and shook their heads. It was technically impossible with the technology available. Kelly Johnson, now 27, and already recognized as one of Lockheed's most brilliant engineers, saw it differently. He didn't see impossibilities. He saw a fascinating puzzle waiting to be solved. And he had a radical idea that went against all fighter design conventions of the time. Conventional wisdom dictated that fighters should have a single, powerful engine mounted in the front, pulling the plane along. This was how all fighters were built. But Kelly saw the limitations of this approach. A single engine large enough to achieve the required speeds would be extremely heavy. This would require a stronger, heavier airframe to support it. The additional weight would hamper climb performance. It was a vicious cycle. Kelly's solution was counterintuitive: use 2 smaller engines instead of 1 large one, but not mounted in the front. That would create excessive drag. Instead, he would mount them in streamlined nacelles on the wings, each with its own propeller. The central fuselage would be a narrow, streamlined gondola housing the pilot and weapons. A twin tail would connect everything. When Kelly presented his initial sketches to Lockheed management, the reaction was skeptical. A twin-engine fighter? That had never been done before. It would be too heavy. Coordinating two engines would be too complex. What would happen if one engine failed? The objections were numerous. Kelly answered each one methodically. Two smaller engines combined would weigh less than one large engine of equivalent power. The wing-mounted engine configuration freed the central fuselage to be extremely aerodynamic, reducing drag. If one engine failed, the other would provide enough power to return to base safely. The twin tail would provide superior stability and better control. He spent weeks performing complex calculations, mathematically proving that his radical design would not only meet Army specifications, but significantly exceed them. He built models and tested them in wind tunnels, refining every surface and angle. The data didn't lie. Kelly's concept was technically sound. Lockheed decided to take a risk. They gave Kelly permission to develop a full prototype based on his revolutionary design. He had less than a year to turn concept into reality. The pressure was immense. If he failed, it could end his career and potentially Lockheed's. If he succeeded, it would change aviation forever. Kelly assembled a small team of equally brilliant engineers and technicians. They worked 12 to 14-hour shifts, solving unprecedented technical problems. Each day brought new challenges, and Kelly was determined to overcome them all. The first prototype of what would be called the P-38 Lightning began to take shape in Lockheed's Burbank hangar in the summer of 1938. It was unlike anything anyone had ever seen. The central fuselage was sleek and narrow, almost like a torpedo with wings. The engine nacelles resembled perfect aerodynamic pods. The twin tails gave the plane an almost alien appearance. Kelly personally oversaw every aspect of construction. He didn't just draw. He was on the factory floor, working alongside mechanics and technicians. When a component didn't fit perfectly, Kelly was there with tools in hand, adjusting and refining. He understood that great designs weren't just theory on paper. They were 1,000 tiny details executed to perfection. One of the most critical challenges was the cooling system. Two 1,150 horsepower Allison V1710 engines generated immense heat. Installed in the wings, away from the direct airflow from the front, cooling was problematic. Kelly designed an innovative system of radiators mounted in the rear sections of the engine nacelles, cleverly utilizing the airflow to cool both the oil and the coolant. Another challenge was the armament. Kelly had decided to concentrate all the weapons in the forward section of the central fuselage. This meant there was no need for propeller synchronization. The weapons could fire directly ahead without risking hitting their own propellers. Concentrating fire on one point would create massive destructive power. But it required careful structural design to absorb recoil. The cockpit was another innovation. Kelly created a spacious and comfortable cockpit with excellent visibility. He understood that pilots would fly long and exhausting missions. Comfort wasn't a luxury. It was an operational necessity that directly affected performance. The instrument layout was intuitive, the controls ergonomic. Everything was designed from the pilot's perspective. By January 1939, the XP-38 prototype was complete. It was impressive even sitting in the hangar. The silver paint gleamed under the lights. The lines were futuristic and aggressive. There was a palpable sense that this was something special. But the real test would come in the air. The first flight was scheduled for January 27, 1939. Test pilot Ben Kelsey inspected the plane carefully before climbing into the cockpit. Kelly was nervous but confident. He had checked every calculation 1,000 times. Theoretically, everything should work perfectly. But theory and reality didn't always agree. The engines roared to life, a deep, powerful sound. The XP-38 taxied down the runway, accelerated, and surprisingly smoothly lifted off. Kelly watched from the ground, barely breathing. The first few minutes were critical. If there were any fundamental design flaws, they would be revealed now. Kelsey radioed back. The plane flew like a dream. The controls were responsive. Stability was excellent. Speed was increasing rapidly. He took the prototype through a series of maneuvers, turns, climbs, dives. In each test, the P-38 performed magnificently. When Kelsey landed after 45 minutes of flight, he was smiling broadly. "Kelly," he said, "you've created something special." Subsequent tests confirmed it. The P-38 not only met the Army's impossible specifications, it dramatically exceeded them. There was just one problem. War was coming faster than anyone imagined. While the P-38 was undergoing testing in 1939, Europe was descending into war. In September, Germany invaded Poland. France and Great Britain declared war. The German Luftwaffe quickly demonstrated devastating air superiority with its Messerschmitt Bf-109s and coordinated bombers. The Blitzkrieg, lightning war, showed the world that air power had become decisive in modern conflicts. The United States officially remained neutral, but military observers sent alarming reports. Existing American fighters were completely outdated compared to the Germans. The P-40 Warhawk, the best fighter in American production, was inferior to the Bf-109 in virtually every respect. If the United States were drawn into the war, it would be at a serious disadvantage. The Army Air Corps dramatically accelerated the P-38 program. They ordered immediate production of 300 units, even before full testing was completed. It was a calculated risk. If serious problems were discovered, hundreds of planes could be rendered useless. But time was more critical than caution. Kelly and his team worked at a frantic pace, identifying and solving problems as they arose during testing. One of the most serious was compressibility. In high-speed dives, the P-38 encountered strange aerodynamic effects near the speed of sound. The controls became extremely heavy or locked up completely. Pilots reported terrifying experiences losing control in dives. The problem was that the P-38 was simply too fast for the conventional aerodynamics of the time. In high-altitude dives, it reached speeds where the airflow over the wings approached the speed of sound, creating shock waves that drastically altered flight characteristics. It was a phenomenon engineers barely understood in 1940. Kelly tackled the problem with his characteristic approach, meticulous testing and incremental modifications. He redesigned the control surfaces, added special fins to improve high-speed handling, and modified the wing profile. It wasn't a perfect solution. The P-38 would still have limitations in very high-speed dives, but it was manageable with proper pilot training. Another challenge was production logistics. The P-38 was more complex than conventional fighters. It had more parts and more sophisticated systems requiring greater manufacturing precision. Scaling production from a few test units to hundreds per month was a massive industrial engineering challenge. Kelly worked directly with factory managers, streamlining processes wherever possible without compromising performance. In December 1941, when Japan attacked Pearl Harbor and the United States officially entered World War II, only a few P-38s were in operational service. The first combat units were just beginning training. Meanwhile, American pilots were fighting P-40s and other inferior aircraft against the Japanese in the Pacific and the Germans in North Africa. The losses were terrible. Field reports spoke of superiorly maneuverable Japanese Zeros shooting down P-40s with ease. Messerschmitts dominated the skies over the Mediterranean. Commanders desperately clamored for better aircraft. The pressure on Kelly and Lockheed was immense. Soldiers were dying while waiting for the lightning. Kelly pushed production even faster. He worked 18-hour days, solving manufacturing problems, training maintenance crews, and consulting with pilots. He knew that every day of delay meant more lives lost. The P-38 needed to reach the battlefield, and when it did, it needed to be devastatingly. Effective. The first P-38 Lightnings arrived in the European theater of operations in late 1942. Pilots who saw them for the first time were simultaneously impressed and skeptical. The plane was undeniably beautiful, with its futuristic lines and shiny silver finish. But it was also large for a fighter, bigger than anything they had flown before. Had it sacrificed agility for speed? Training quickly dispelled any doubts. The P-38 was unlike anything American pilots had experienced. With two engines totaling 2,300 horsepower, acceleration was brutal. A top speed of 414 miles per hour at 25,000 feet made it one of the fastest fighters in the world. Its climb rate was exceptional. It could reach 20,000 feet in less than 7 minutes, but it was the combat characteristics that truly impressed. The concentrated armament, 4 50-caliber machine guns and a 20mm cannon, generated devastating firepower. Because all the weapons were located in the central fuselage, there was no dispersion. The projectiles converged on a single, lethal point. A 2-second burst from the P-38 could literally cut an enemy aircraft in half. Range was another crucial advantage. With full fuel tanks, the P-38 could fly over 2,100 miles, more than twice as far as most fighters. This meant it could escort bombers deep into enemy territory, something impossible for single-engine fighters. Bomber pilots would soon learn to love the sight of lightnings flanking them. The first significant combat came over North Africa in November 1942. Squadrons of P-38s faced Messerschmitt Bf 109s and Focke-Wulf, Versatility of the Luftwaffe. The German pilots, seasoned veterans with years of combat experience, expected to easily outmaneuver the fledgling Americans. What happened completely surprised them. The P-38s used their advantages of speed and firepower brutally. They attacked from high altitude in high-speed dives, fired devastating bursts, and accelerated away before the Germans could react. If the Germans tried to pursue, the Lightnings simply drove them away. It was a new tactic based on the aircraft's unique capabilities. Reports from the field began to arrive. A P-38 had shot down 3 Bf-109s in a single engagement. Another had destroyed a Junkers Ju-88 bomber with a single burst. The loss ratios were favorable. For every Lightning lost, 2 to 3 German aircraft were shot down. Pilots who were initially skeptical of the unconventional design became fanatical. Believers, the Germans quickly developed a healthy respect for the P-38. Luftwaffe pilots reported that the American twin-tailed plane was a formidable adversary. Some called it the Gabelschwanz Teufel, the fork-tailed demon. There were specific instructions on how to combat it. Never attempt to compete in speed or climb. Avoid head-on engagements and attack only if you have a significant numerical or positional advantage. In the Pacific, the P-38 found even greater success. Against the agile but lightly armed Japanese Zeros, the tactic was similar. Use superior speed and firepower to avoid prolonged maneuvering engagements. Extended range was particularly valuable over the vast distances of the Pacific. Lightnings could escort bombers across hundreds of miles of ocean, but the P-38's true test would come on one of the most audacious and important missions of the war. And Kelly Johnson had no idea that his plane was about to dramatically change history. In April 1943, American intelligence intercepted and deciphered a Japanese message revealing something extraordinary. Admiral Isoroku Yamamoto, architect of the Pearl Harbor attack and supreme commander of the Imperial Japanese Navy, was to conduct an inspection of bases in the South Pacific. The message included his complete itinerary, including exact arrival and departure times. Yamamoto was more than a military officer. He was the strategic genius behind the initial Japanese victories. His death would be a devastating blow to Japanese morale and command capabilities. But there was a critical problem. Yamamoto would be on Bougainville, deep in Japanese-held territory, more than 400 miles from the nearest American base on Guadalcanal. No American fighter had sufficient range to fly the mission, except one. The P-38 Lightning, with auxiliary fuel tanks, could theoretically make the round trip, but it would be a mission at the absolute limit of the plane's range. Any diversion, any prolonged combat, and the pilots would have no fuel to return. The mission was approved at the highest level. President Roosevelt himself personally authorized it. It was designated Operation Vengeance. 16 P-38s from the 339th Fighter Squadron were selected. The plan was to fly extremely low over the ocean to avoid Japanese radar detection, intercept Yamamoto's plane exactly at its scheduled arrival time, shoot it down, and return before Japanese fighters could react. It was incredibly risky. The pilots would have to navigate perfectly across more than 400 miles of ocean, using only compasses and stopwatches. An error of even a few degrees would mean missing the target completely. They would have to time their approach to intercept Yamamoto at just the right moment. And they would have to do all this while flying just 50 feet above the waves to avoid detection. On the morning of April 18, 1943, 16 Lightnings took off from Henderson Field on Guadalcanal. Each carried auxiliary fuel tanks mounted under the wings, giving them the necessary range, but also making them less agile. The pilots flew in absolute radio silence, maintaining close formation just a few meters above the waves. Navigation was the responsibility of Lieutenant Rex Barber, who used meticulous calculations and constant course adjustments. For 2 hours, the P-38s roared across the ocean, salt water spraying from their propellers. Some pilots later reported seeing sharks swimming below them. At exactly 9:35, when the calculations predicted, the pilots spotted 2 Mitsubishi Betty bombers, escorted by 6 Zero fighters, exactly as intelligence had predicted. Yamamoto was in one of the Bettys. The auxiliary tanks were jettisoned immediately. 4 P-38s climbed to engage the Zeros, the others dived on the bombers. What followed was a frenetic and brutal dogfight. The Zeros desperately tried to defend the bombers, but the P-38s were faster and the American pilots were determined. Lieutenant Barber positioned himself behind one of the Bettys and opened fire. His 20mm cannon and machine guns ripped through the bomber's fuselage. The Betty, with Yamamoto inside, attempted to escape by flying low over the jungle. Barber pursued relentlessly, firing burst after burst. The bomber began to emit smoke, then burst into flames. It crashed into the jungle and exploded. Admiral Yamamoto died instantly on impact. The P-38's most important mission had been executed with deadly perfection. After Operation Vengeance, the P-38 Lightning solidified its reputation as one of the most lethal fighters of World War II, but it was its daily operations over Europe that truly demonstrated the versatility and capability of Kelly Johnson's design. In the European theater, the P-38 found its primary role as a long-range escort fighter. Formations of B-17 Flying Fortress and B-24 Liberator bombers penetrated deep into Germany, attacking factories, refineries, and infrastructure. These missions were extremely dangerous. Without escort, bombers were slaughtered by German fighters. The Luftwaffe had developed tactics specifically to destroy these heavy bomber formations. The P-38, with its exceptional range, dramatically changed this balance. For the first time, bombers had fighter protection throughout the mission. German pilots who had previously been able to attack bombers with relative impunity now faced aggressive Lightnings, protecting their precious cargo. The statistics told the story. Before the introduction of the P-38 as a long-range escort, the bomber loss rate on deep missions often exceeded 10%, unsustainable in the long run. With Lightning escort, losses dropped to 2 to 3%. Every P-38 in the air meant dozens of bomber crews returning alive. P-38 pilots developed sophisticated tactics specific to their unique characteristics. One was the boom and zoom, diving from high altitude with tremendous speed, firing a devastating burst, and accelerating back down return to altitude before enemies could react. The P-38's superior speed made this extremely effective. German fighters simply couldn't keep up. Another tactic exploited massed armament. In head-on combat, normally considered extremely risky, the P-38 had a decisive advantage. Its weapons converged perfectly in the center, while German fighters with wing-mounted armament were significantly dispersed. Experienced Lightning pilots could shoot down enemies in head-on passes that would have been suicidal for other aircraft. The European winter of 1943-1944 brought new challenges. Extremely low temperatures at high altitudes caused problems with the Allison engines. Oil froze, radiators cracked, and engines failed. Kelly Johnson, still overseeing modifications and improvements in California, worked frantically on solutions. New heating systems were developed, special cold-resistant fluids were formulated, and operating procedures were adjusted. American aces began to emerge, flying P-38s. Richard Bong, the leading American ace of the war with 40 victories, flew exclusively Lightnings. Thomas Maguire, the second leading ace with 38 victories, was also a P-38 pilot. Both operated in the Pacific, where the Lightning truly shone against the Japanese. In the Pacific, the P-38 was virtually invincible when flown correctly. Its superior speed meant it could choose when to engage and when to retreat. Zeros and other Japanese fighters were more maneuverable at low speeds, but in high-speed combat they were completely outclassed. American pilots learned never to attempt to compete in low-speed maneuvers. Always use speed and energy. The P-38's versatility was remarkable. In addition to fighter and escort roles, it was used as a fighter-bomber, carrying up to 3,200 pounds of bombs. Photographic reconnaissance versions, unarmed but equipped with cameras, penetrated deep into enemy territory, photographing strategic targets. Some variants were adapted as night fighters. Kelly's fundamental design was so solid that it accepted extensive modifications. In June 1944, when Allied forces invaded Normandy on D-Day, P-38s were among the first planes over the beaches. They provided close air cover for the landing troops, attacked German fortifications, and engaged any Luftwaffe fighters brave enough to show up. In the skies over France, the distinctive twin-tail profile became a symbol of liberation. But perhaps the most significant tribute to the P-38 came from its enemies. Captured German pilots consistently ranked the Lightning among the most feared Allied fighters. They respected its speed, firepower, and versatility. One veteran Luftwaffe pilot said during interrogation, "The P-38 was an adversary we never underestimated. It was fast, deadly, and flown by Americans who learned to use its advantages perfectly." Kelly Johnson rarely spoke about his role in creating the Lightning. For him, it was just work, solving technical problems, improving designs, supporting the pilots who risked their lives. But as the war raged on, it became clear that his impossible plane was changing the course of the conflict. By the time the war in Europe drew to a close in 1945, more than 10,000 P-38 Lightnings had been produced. The aircraft had flown in every theater of operation, from the freezing cold of Alaska to the scorching heat of the South Pacific. It had shot down more enemy aircraft than any other American fighter in the Pacific. It had escorted countless bombers home safely. It had saved literally thousands of lives. But for Kelly Johnson, the P-38 was just the beginning. The experience of designing and refining the Lightning under extreme pressure had taught him valuable lessons. He had learned that radical and unconventional designs could succeed if based on sound engineering principles. He had learned the importance of working in small, focused teams without excessive bureaucracy. He had learned that simplicity and efficiency trumped elaborate complexity. In 1943, while the P-38 was proving its worth in combat, Kelly was working on something even more revolutionary. Lockheed had been chosen to develop the first American jet fighter. Kelly led the project, applying the lessons learned from the Lightning. He assembled a small team of exceptional engineers, sequestered them in a separate facility away from corporate bureaucracy, and gave them complete freedom to innovate. The result was the P-80 Shooting Star, developed in just 143 days, an extraordinary record. The aircraft flew days before the end of the war in Europe, arriving too late for significant combat. But it established the United States as a leader in jet aviation technology. And the development method, small team, maximum range, focus on practical results, became the model for future projects. Kelly formalized this approach by creating what became known as Skunk Works, a special division of Lockheed dedicated to advanced and secret projects. The name came from a popular comic strip, but the concept was serious. Skunk Works would operate outside normal corporate structures, with minimal oversight and maximum creative freedom. It was the opposite of how large corporations typically operated. Kelly's operating principles for Skunk Works were simple yet revolutionary. Small teams of exceptional people, direct authority from the project manager over all aspects, minimal documentation and bureaucracy, physical proximity between engineers, manufacturers, and test pilots, rapid iteration, based on real-world testing rather than prolonged theoretical analysis. This was essentially how he had developed the P-38, now codified in formal methodology. Over the following decades, Skunk Works, under Kelly's leadership, would produce some of the most iconic and advanced aircraft in history. The U-2, a high-altitude spy plane that flew above 70,000 feet. The SR-71 Blackbird, still the fastest manned aircraft ever built. Capable of Mach 3.3, the F-117 Nighthawk, the first operational stealth aircraft. Each pushed the limits of the technologically possible. Kelly received numerous awards and honors. The National Medal of Science, 2 Collier Trophy Awards, the Institute of Aeronautical Sciences Sylvanus Albert Reed Award. He was inducted into the National Aviation Hall of Fame. But when asked about his achievements, Kelly consistently deflected credit to his teams. "I just remove obstacles," he would say. Talented people do the real work, but those who worked with Kelly knew the truth. His genius lay not only in technical design, but in creating environments where innovation flourished. He shielded his teams from corporate politics. He fought for the resources they needed. He made decisions quickly. And always he focused on practical results. Rather than theoretical elegance, the Michigan boy who dreamed of wings had become one of the greatest aeronautical innovators in history. Kelly Johnson retired from Lockheed in 1975 after 42 years transforming aviation. He was 65, an age when most people slow down. But Kelly had lived several lifetimes of achievement. More than 40 aircraft bore his name as principal designer or key contributor. His inventions had flown higher, faster and farther than anyone in the previous generation could have imagined. But Kelly's legacy transcended specific aircraft. He had fundamentally changed how complex engineering projects were approached. The Skunk Works methodology he created became a model studied in business and engineering schools around the world. Large corporations sought to replicate his principles: small teams, autonomy, rapid iteration, and a focus on results. The P-38 Lightning, where it all began, became an icon of aircraft design. Decades after the war, enthusiasts painstakingly restored Lightnings. Flying examples appeared at air shows, their distinctive twin-engine sound still capable of drawing crowds to their feet. Museums proudly displayed P-38s, recognizing their crucial role in the Allied victory. Pilots who had flown Lightnings in combat maintained veterans associations, meeting annually to share memories. Many attributed their lives to the plane, whether its speed allowed them to escape impossible situations, its endurance bringing them home with a destroyed engine, or its firepower saving them in desperate aerial combat. The P-38 wasn't just a machine to them, it was the brother who had fought alongside them. Kelly rarely attended these meetings. He was fundamentally modest, uncomfortable with attention. When he occasionally appeared, pilots surrounded him, wanting to shake hands with the man who had created the plane they loved. He listened to their stories with genuine attention, asking technical questions about performance under specific conditions. Even in retirement, Kelly was an engineer to the core. In later interviews, Kelly reflected on the irony of his career. He had been rejected by the Air Force because of vision problems. That rejection, devastating at the time, had forced him to find another path. Had he been accepted as a pilot, he likely would have had a respectable but unexceptional career. Instead, the rejection pushed him onto a path where his truly extraordinary abilities could flourish. Sometimes, he once said, what seems like our greatest defeat is actually the necessary redirection for our greatest triumph. If I had become a pilot as I planned, I never would have designed the P-38. I never would have created Skunk Works. Thousands of planes would never have been built. It's a lesson in accepting when life changes our plans. Kelly Johnson passed away in 1990 at the age of 80. Obituaries in newspapers around the world celebrated his achievements. Lockheed lowered flags to half staff. NASA and the Air Force issued statements honoring his contributions. But perhaps the most meaningful tribute came from a veteran P-38 pilot who wrote a simple letter published in an aviation newspaper. Kelly gave us wings when we needed them most. He gave us speed when we were being pursued. He gave us firepower when we were desperate. He brought us home when we thought we would never return. We who flew his planes owe our lives to a man who could never fly with us, but who gave us the sky anyway. Thank you, Kelly. You saved thousands of us. The boy who dreamed of wings had given wings to the world, and those wings had changed history forever.